Welcome to a video lesson on the law of cosines. Say, if you like the law of sines, you'll definitely enjoy the law of cosines. There are actually 3 laws in one, but don't worry, you don't have to freak out about memorizing these laws. They're very similar in the structure of the actual laws. So what are those 3 laws? Let's take a look. The first one is, mostly if we're trying to solve for A or whatever, either A, little side A or actual angle A. So kind of looks like the Pythagorean theorem. A squared equals B squared plus C squared minus 2BC cosine A. Of course, that's being multiplied there. So I want you to notice the connection here. The BC side is also being multiplied next to cosine A. The second one is very similar, except we're solving for B, so B squared equals A squared plus C squared. There you have it. A squared plus C squared minus 2AC cosine A. Of course, we'll do some examples using these. And the third one, as you might expect, is when we're solving for C or big C. So C squared equals A squared plus B squared minus 2AB cosine big C. Those are the 3 laws that we would use to solve triangles using, oh no, we should know this for sure. Okay, side, angle, side, and side, side, side. That's when we'll use the law of cosines. Now, how would we know if we're actually using those triangle congruence theorems? We'd have to actually sketch the triangle to see what it looks like. And some of you might even be able to identify just from the provided information what sort of theorem will be involved in that. So let's take a peek at an example here. I have in yellow, we're solving that a triangle has little a side of 10, b side of 4, and angle C is equal to 25 degrees. Just a quick note on sketching this triangle before we actually solve for some sides. I want to point out that I would sketch the horizontal side, the actual floor of the triangle, I guess you might say, the base. And, I didn't know right away that this was B, but I decided that my side A would be the longer side. Well, sorry, my side A would just be on top, so that what? You know what? I think it really doesn't matter in this case. So because we have our side and angle in between and the side, I just don't think that it matters. The main thing that matters is that you would sketch this with some sort of proportion, the fact that A is larger. And if you just use your fingers, you don't really need a ruler or anything like that. Just A must be at least 2 times larger than B. And with my picture, I think it does the trick. But that angle C is really the key part, that we would sketch that first. So sketching B a little bit and A a little bit, having a triangle, that angle there of 25 degrees, and making it, kind of half of 45 degrees or so. All right, so now we have our picture, and then we'll start to solve that. So let's just start with solving for C first. And so I'll go back to the previous page here, and you'll see that the purple equation is what we'll actually want to use here. So I'll apply that. So plugging in what I know, C squared is equal to 10 squared plus 4 squared minus 2 times 10 times 4 times cosine 25. So the one thing that you definitely don't want to do, because it's against the rules of mathematics, is when you combine this 10 squared and 4 squared, that you would subtract this 2 times 10 times 4, which is 80. That would be against the rules of order of operations. We need to multiply cosine 25 by this 80 over here. So basically I'll simplify next to see what we get here. So notice I didn't combine that, 116 and 80. So 116 minus 80 cosine 25. Okay, I could have taken a step in between there, 100 and 16 and so forth. So at this point, because we're dealing with cosine 25, which is not a special angle, right to the calculator. One line in the calculator using degree mode gives us a C squared value of 43.5. So what I'd like you to do now, if you have your calculator handy, is actually punch that into the calculator, 116 minus 80 cosine 25. And what we're about to do is we're going to take that information, that value, and we want to store that C value that results of square rooting 43.5-ish. You know, you'll get a longer decimal on your calculator. So I got 43.49537704. Okay, now stick with me here. It's important that you get this piece because we want our calculations to be as approximate as possible. So on your calculator, take that value and just square root, so second squared, just square root, which is 1, 2, 3, 4, the fifth button from the top on the left, and then second answer, which is second negative sign, and you should get C equals 6.6-ish. So 6.595, 102, etc. Okay, if you follow me so far, you have a wonderful, very approximate answer to 9 decimal places in your calculator right now. Okay, we're about to use this C value in the next part of Law of Cosines in calculating whatever other angle that we're going to choose to calculate. So on your calculator, I would like you to store that value as C. So stick with me here, press the store button on the left side of your calculator. So it says stow with an arrow. Okay, and then alpha, press the alpha button and then the program button. So alpha program gives you, it says on your screen, answer arrow C, and because alpha program is the letter C in green, so it corresponds with the alpha button in green. Alright, then press enter, and that will have stored that value in as C. Okay, so that's a great resource. You could store it as A, B, C, D, whatever you want, all the way up to Z, even theta if you want, which is the number 3. Now, just to check what you did is correct or it actually worked, press alpha program again, press enter, and then you should get that same value. So on your calculator screen, you should see 3 values for 6.595 on the screen. And I show you that now because what we're about to do is use that C value. And we don't want to use 6.6 because it's not very approximate in what we're doing. Okay, so let's go ahead and solve for another value on the triangle. So I'm randomly choosing angle A here. I could have chosen angle B if I liked. But now what we'll do is we'll basically use the same formula, but we're going to use the formula that deals with angle A. So the first formula in black is what we'll use. Alright, so check it out. Let's go set that up here. So little a, which is 10, so 10 squared, equals, well, now we have all these values, right? So 16, well, I'll write that as 4 squared. Alright, then plus C squared. Now notice I'm just putting C squared right now, and I know that I have that stored in my calculator, so later we'll actually use that value in there. Alright, so 2 times 4 times C times cosine angle A. Alright, ultimately we're going to get an answer and we'll have to calculate second cosine of whatever we have and work with that. Okay, so there are actually 2 ways we can work with this. We could actually add this 8c, this negative 8c cosine A to the left side, or subtract the 4 squared and c squared. I'm going to choose the 4 squared and c squared just because that's what I have in my notes. So here we go. Okay, so I have 100 minus 16, which is 84, minus c squared equals negative 8c cosine A. So just a little bit of algebraic here, that's the algebraic work here that's happening, and so now at this point we want to basically isolate cosine A. So what we'll do is divide by negative 8c. So we have 84 minus c squared over negative 8c, which is our cosine A. So that looks a little bit tricky, and especially if we punch that in the calculator, we need to be really careful as we enter that with parentheses and stuff, otherwise we'll get a quite incorrect answer. So the last thing that we'll do is take the second cosine, or take the arc cosine of both sides. And so I'll write that to the right here. So that becomes, I'm not even going to use that arrow, it could be confusing. Cosine inverse of 84 minus c squared over negative 8c equals A, big A. That's what it equals. So a somewhat foolish thing would be to say the answer to whatever this was on the left side was the actual answer, which is going to be quite a small decimal. But the correct answer is actually what we're putting in over here, arc cosine. And so just be careful here. What we're about to do is use parentheses here, and that's what you'll need in the calculator. So I'll go right to the calculator and join me with this second cosine. Open parentheses 84 minus c squared, so alpha program squared, close parentheses. Now if you're using the fraction piece on your calculator, that's great. Go ahead and use that. I'm just right typing it in as normal. Divided by, open parentheses, negative 8 alpha program, which is c. And then I'm closing two parentheses like so. And hopefully you're following along, you can get that piece. And my answer that I get for angle A is equal to 140 degrees, 0.15. Okay, that's fantastic. Oh my gosh, if you got that answer, give yourself a high five. And I'm just about to look up back at the picture here, and I noticed that angle A is looking like it could be 140 degrees. That's pretty awesome. Okay, and then I'll just round some answers here. So 140 and 25, which is 165, I could round B to 15 degrees. 15 plus 25 is 40, plus 140 is 180. Now, if I would have rounded before, maybe I would have gotten 139 or 141, which is not a big deal. We're practicing and stuff like that. But then the answer for angle B would actually be another rounding that we're doing. So if you don't round in the preliminary steps, then rounding in the final step gives you a quite accurate answer. Okay? Hey, that's all there is to the law of cosines. Like I said, after we found the actual third side C, we could have used the law of sines from there. But I stuck with the same law so that we wouldn't get confused. Alright, fantastic. Hey, we've solved the triangle, so thanks a bunch for learning with me, and I will just leave you with this wonderful image. Bye-bye.